Good day, everyone. For today, we are going to discuss a topic in general mathematics, which is functions, relations, and functions as models. But before that, let me ask you a question. What comes into your mind when you hear the word relation? You might think of it as the relationship that exists between persons, animals, things, or objects, and you are correct. An example of relation that exists between persons are father and son, mother and daughter, couples whether they are dating or married, teacher and students, or a lion and his cub. You may also think of it as pairing. For example, spoon and fork, cup and saucer, pen and paper, mangga at bagoong, suman at halya, or a burger and a fries. All of those are examples of relationship that exist between persons, animals, objects, or food. But how do we define relation in mathematics? In mathematics, we define a relation as a set of ordered pairs x and y. Another term for ordered pair is coordinates or a point in a Cartesian plane. Ordered meaning there is an arrangement. The first element of an ordered pair is called the x-coordinate or abscissa, and the second element of an ordered pair is called the y-coordinate or ordinate. They are usually enclosed in a parenthesis. But what do we mean by a set? A set is a collection of well-defined elements or distinct members. Well-defined or distinct. For example, A is the set of counting numbers. The distinct numbers or element that we are looking for is a counting number. So we can represent it like this. A equals 1, 2, 3, 4, 5, and so on and so forth. So the elements are counting numbers. Another example, a set of even numbers. So this time let us represent the set as x. So we have 2, 4, 6, 8, and so on and so forth. So they are usually separated by a comma and they are enclosed in a braces. Going back to the definition of relation, this one is an example of a relation. We have here 5 ordered pairs. Each ordered pair is separated by a comma and they are enclosed in a parenthesis. Okay? Those 5 ordered pairs is again separated by a comma and they are enclosed in a brace. This is how you represent a relation. You may use any capital letter in the alphabet. For instance, this one is set A. Let's have another example. We have set B. Okay, this time you only have 2 ordered pair, okay, separated by a comma, enclosed in a brace. A set could be empty or consist of one or more elements. This time, let's have the domain and range. Now, let's have this example relation. So, when we say domain, it is the set of all x values in the relation. So, this is simply the abscissa in each ordered pair. So, you write it this way. Since it is a set, it is enclosed in a braces and then separated by a comma. Now, this is also called, domain is also called the input values. Okay? While a range is the set of all y values or ordinates in the relation. So, these are simply the x values or the ordinates. So, you have 3, 5, negative 2, 9, and negative 6, and they are also called the output values. Now, if the element in the set appears more than one, for example, twice, So, you simply write it once. Okay? So, instead na magiging 5 ang inyong range, magiging 4 na lang siya. Kung ang 3 ay 2 beses nyong nakita doon sa part na yon. Now, same goes with the domain. So, the element is only written once if it appears more than 1. Okay? So, this time, let us define a function. A function is a special type of relation such that no two distinct members have the same first element. Again, a function is a special type of relation, special type, meaning there is a condition. The condition is no two distinct members have the same first element. When we say distinct, they are not the same. They are two different numbers or two different elements. And when you say first element, we are referring to your abscissa. So, for it to be a function, your abscissa should not be paired to two or more different numbers. Okay, remember that. Your abscissa should not be paired to two or more different numbers because it is a special type of relation. Okay. Since you know the definition of functions and relation, let us now try to answer these questions. Are all functions a relation? Are all relations a function? Which do you think of these two questions is true and which is false? Okay, so are all functions a relation? True or false? So the first statement is true, but the second statement is false. Why? Because all functions are relation, but not all relations are functions. Because we define a function as a special type of relation. So meaning, for a relation to be a function, there is a certain characteristic that it should possess. For instance, in our definition, your first element should not be paired to two different values of y. So, not all relations are functions. There are ways to represent functions. First is numerically using table of values and set of ordered pair. The next one is graphically by means of graphs, mapping, or arrow diagram. And then we also have algebraically using an equation. And the last one is verbally using a rule of correspondence. Okay. So this time, let me show you how to represent a function numerically. The first one is through a set of ordered pairs. For example, you have here set A, 1, 3, 2, 5, 3, 9, and 4, 17. This could also be written through a table of values, whether it is horizontally or vertically. You will notice here that the set is also the same as the values here in the table. So meaning when it is written in a set of ordered pairs, you could also write it using table of values. So they are just the same. And this is the easiest way on how to determine whether it is a function or not. We know that this is a relation, but is it a function? So how are you going to do this? If it is given, if a set is given or a table of values, all you have to do is to look at your abscissa, okay, the first element. So look here. Okay. If your abscissa is not repeated, for instance here 1, 2, 3, 4, so there is no number which is being repeated. So that means it is distinct. So the elements in Y are also distinct. Okay? So meaning this is a function. So that is the easiest way. All you have to do is to look at your x values. If the x values is not paired to more than two different elements in Y, so it is a function. So this time, let's have some exercises. Determine if the relation is a function or not. Let's have set x. So again, as I have mentioned earlier, all you have to do is to look at the abscissa. -3, -2, -1, 0. So the first element is not repeated. So this one is a function. Let's have set number 2. Set y. So here, 0 is being repeated, and it is paired to two different numbers. You have here positive 1 and negative 1. They are distinct. So this time, it is not a function. Let's have number 3, this time a table. Again, look at your x values. Okay. Although your y values here is being used twice, being paired to 2 and to 4, it doesn't matter since it is a y value, so it is still a function. All you have to do is to look at the x value. Number 4, let's have, here again, 0 is being repeated to 3 or being paired to 3 and 6. So this time, it is also not a function. Now, you can think of x as the man or the domain as the man and the y or the range as the woman. What does this mean? It means that the man should be loyal to the woman. He should not be paired or have a relationship with other women or with other girls. She doesn't have a fling with other girls or any other relationship. That is one application of function in real life situations. So being loyal to your partner. We can also represent function graphically. One is through graphs, and the other one is using mapping or arrow diagram. But how can you determine whether the graph represents a function or not? To determine whether a given graph is a function or not, we will be using the vertical line test. It states that a graph is a function if any vertical line drawn passing through the graph intersects the graph at exactly one point. So let's have an example. So here we have three graphs. For letter A, using the vertical line test, so we draw a vertical line. And if you will notice, on that part of the graph, it will only intersect at one point. So since this is a continuous graph, there is no vertical line here. And then, if we move along, going here, up to the end of the graph, it will still intersect the graph at exactly one point. So, meaning this one is a function. So, you have to test the vertical line all throughout the graph. Okay? And then, if all throughout the graph, it only intersects at one point, it is a function. For number 2, we have here a diagonal line. So, we can easily determine this one because this is just simply a straight line. So, all throughout, if you imagine that vertical line moving along, all throughout the diagonal line, it will only intersect at one point. So, this time, it is also a function. For the last example, you have here letter C, a circle. At the beginning, when you draw a vertical line here, it will only intersect at one point, which is at the point of tangent C. Okay? But moving along, all throughout, this vertical line will intersect the circle at most at 2 points. So, the most number of points that it will intersect is 2. So, this one is not a function. Again, for it to be a function, when you use the vertical line test, that vertical line should intersect the circle, should intersect the graph all throughout at exactly one point only. If it is more than one point, let's say it intersects at 2 points, 3 points, 4 points, then it is no longer a function. Is that clear? Another way to represent a function graphically is through mapping or arrow diagram. So let's have an example. So here, the first circle represents your domain or the x values, and the second circle represents your range or the y values. Since you will notice the correspondence here or the relationship that exists between 1, 2, 2, 4, 3, 6, 4, 8, 5, 10 is a one-to-one correspondence. Since it is one-to-one, okay, this one is a function. So, the man is loyal to his partner, which is the woman. So, there is only one pairing. So, one-to-one correspondence is a function. Let's have another one. This one is a one-to-many correspondence. Okay? No, correspondence is one-to-many. Meaning your x here, your domain here A, is being paired to 5 different y values. So, since this is one-to-many, polygamous yan, so this one is not a function. Let's have number 3. This one is the other way around. So, this is many-to-one correspondence. But a many-to-one correspondence is a function because your range is the one being paired to different y's, or different x rather. So this is a function. A many-to-one correspondence is a function. And this one is many-to-many. Why is it many-to-many? Here you have here A is being paired to 1 and 0. And then here you have B is being paired to negative 1, to positive 1 rather, and 3. So here in the x, there are different pairings. And then when you go to the range, here you have 1 is being paired to A and D. And then you have here 3 is being paired to D and E. So this is a many-to-many correspondence, and therefore it is not a function. So all you have to do is to remember the correspondence and the corresponding answer, whether it is a function or not a function. Let's move on to the third way of representing a function, which is algebraically, meaning the given is an equation. So for number 1, the answer here is a relation or not function. Number 2, we have here function. Number 3 is also a function. Number 4 is not a function, or it is merely a relation. 5 is a function. 6 is also a function. And 7 is not a function, it is just a relation. So how do we get these answers? You just simply observe the exponent of y. Okay? And observe the exponents of y in each equation. So you will notice that if the exponent, okay, the exponent of y, okay, is 1, like this one, and this one, they are function. Okay, so the exponent has only 1, is only 1. So this is a function. But if the exponent is greater than 1, for instance here 2, so relation lang siya. We have here 3, exponent is 3, relation. We have here 2 also, so it is also a relation. So therefore, to determine whether it is a function or not, all you have to do is to observe the exponent of the y variable, and it should not be greater than 1. If the exponent is 2, 3, 4, then it is merely a relation or not a function. We can also represent function verbally. There is a rule of correspondence, and it is stated in words for through a question. For example, the difference between x and y is 8. This English phrase can be translated into mathematical phrase or equation such that x minus y is equal to 8. Observing the exponent of y, which is only 1, so therefore it is a function. Number 2. Zip code in relation to the residents in a town. For instance, the Pilar municipality has a zip code of 2101, and all the residents here is using that zip code. Okay. Analyzing the relationship, one zip code to all the residents, so that is one to many, and therefore it is not a function. Next we have, is age a function of height? So again, let's analyze this. If we have an input age of 20 years old, okay, it could produce a different output of height. Some could be taller than the other, and some could be of the same height. But then, this one is not a function. So age is not a function of height because you could produce different heights with one age, or one height could also produce different age. Okay, so I hope that is clear. For this type of given, you have to analyze the statement or rule to determine whether it is a function or not. This ends the first part of the discussion. Please watch the next video for the second part and visit the Google Classroom for your activities. Thank you.